Welcome to Unit 2, Lesson 6 of Intermediate Algebra, where we solve absolute value equations. So here are our lesson objectives. We should be able to find all solutions to an absolute value equation, assuming the solution exists, and we should be able to determine when a solution does not exist. What does absolute value mean anyway? Understanding the meaning is helpful to why we get two answers for a lot of these. So you can think of absolute value as how far away from zero a number is, if you think of the absolute value of a number. So if I draw a number line, and this is 0, if I say my number is a distance of 5 away from 0, which is what this equation is saying. It's saying my number is 5 away from the 0. What are possible values for my number? Or give me all the numbers that are 5 away from 0 is a better way of thinking about it. So 5 is the quick answer. That's 5 away from 0. This distance is 5. But if we're just talking about distance and we don't care about direction, I can go 5 to the left. And where that lands me is -5. So 5 and -5 are both solutions to the absolute value. Numerically, when we write the absolute value of a negative number, it gives us a positive number. The absolute value of a positive number does not change the number. So basically what an absolute value does to numbers is if the number is negative, it changes its sign. If the number is positive, it just spits out the number you started with. So these have two solutions for this reason. It's a distance problem. When I just say x equals 5, there's one answer and it's right here. But if I say the absolute value of x is 5, I also have to consider the fact that I might have moved 5 from 0 in the negative direction. So here are the steps. These would be helpful when you're trying some of the problems. The fact that the absolute value of something equals a number is what we need to get. Sorry, I should just write number equals some number is what we need to get our problem down to before we can apply the rest of the steps. If I have a bunch of stuff added and multiplied, I want to get this absolute value alone, because only what's in the absolute value has this characteristic of being either negative or positive. When you add 5, you add 5. You don't either that or subtract 5. So you want to get absolute value by itself. So once you isolate the absolute value, if you end up with a negative number, there's no solution, because an absolute value takes the negative sign off of everything. So if I say the absolute value of x equals -2, there's no number I can put in for x and get a -2, because an absolute value always results in a positive quantity. So then if we do have a positive number on the right, we need to solve both cases. The case where what's inside the absolute value is positive or equal to the number, in the case where the absolute value started out as being the negative of the number, but the absolute value turned it into the positive. So, for the simplest equation we had on the last slide, that turns to either x is 5 or x is -5. Now, there was nothing else to do to solve to isolate the x, but that same principle applies if I have something more complex than x. So if I have 2x minus 1 equals 5, my two equations are 2x minus 1 equals 5, just like it says, and then 2x minus 1 equals -5. Now I solve both of these problems. So here's one that's got something just beyond x. I want to find out what the value of x is, and what I'm told is that when I subtract 2 from x, I get a value of 5. So my absolute value is already isolated. It's got nothing multiplied, nothing added, nothing to the left or right of it. So I write 2 equations and I solve the 2 equations. I solve this one and I get x equals 7. I go to the right side here and I solve this one. Now notice the process for isolating the x will be the same, but the results will be different. And I get x equals -3. On the number line, what this looks like is there's 0 and there's 2. Really, this is the difference between x and 2 is 5. 1, 2, 3, 4, 5 brings us to 7. 1, 2, 3, 4, 5 brings us to -3. So if I go 5 in either direction, there are my 2 solutions. Here this is typed out neatly for you. I just thought it might be easier to follow as I wrote, but that's the process. Okay, this one, the first thing I check is the absolute value by itself on the left side, and it is. So I can take what's inside the absolute value and write my 2 equations. And then I solve each. So I have 3x plus 2 equals 15. I subtract 2 from both sides to get 3x equals 13. And then I need to divide by 3 to get x alone. And the process is the same for the second one, but when I subtract 2, I get a different value. So I subtract 2 from both sides and I get 3x equals -17. I divide by 3 and I get x equals -17/3. It does not always happen that one answer is positive and one is negative. That's just happened in these first 2 examples. So this one, you could get away with forgetting to isolate the absolute value, but don't do that. It's bad practice. So the first thing I have to do is get this piece by itself. So what is the absolute value? What is done to the absolute value? Well, it's multiplied by 2. So I divide both sides by 2. And I get, so dividing by 2 there reduces, dividing by 2 there gives me 8. Now my absolute value is by itself and I can write my 2 equations. Do not skip that isolation step. That's where students go wrong with these problems. So there's the step where I isolate, and then I have 4 minus x equals 8. Well, I want to get x by itself. I see there's a positive 4 kind of tacked on to the end of the x term, so I subtract 4 from both sides, and that gave me negative, so that made that 0. And that made the right side 4. Negative x is 4. If I divide both sides by a -1, I get x is -4. Or if I just recognize that I'm saying the opposite of x is 4, then x must have been -4. Here the steps are the same. On the right, you subtract 4, but this time I get a -12 there. Negative x is -12, x is 12. If I plug these back into the original equation, both of them will produce correct results. I will get a true equality. So I take the negative, I do 4 minus a -4 to check the first one, and I'm checking to see if this equals 16. I get 2 times the absolute value of 8, because when I subtract the negative, it's adding, and that is 16. I do the same thing for the 12. 2 times 4 minus 12 equals 16, this will give me a -8, but the absolute value of 8 is -8 is 8, and that indeed is 16. Now I used a different letter just to make sure that won't confuse you. I don't think it will at this point. Absolutely have to first get the absolute value by itself. I do this by subtracting 3 from both sides. That gives me this equation to solve. The 7 is positive. I can write my two equations. So there's that first step done. Do not skip that first step. I think everybody focuses on, oh, I got to write two equations. But when you write the two equations is just as important as writing them. So 2n minus 1 is 7. That means either 2n minus, the absolute value of 2n minus 1 is 7 means either the inside, excuse me, was 7 or it was -7. I add 1 to both sides. I get 2n is 8, n is 4. I do the same thing to the right, but when I add 1 to a -7, it gives me -6, and there are my two answers. Again, I can put in 4 for n and check this. I get 2 times 4 is 8, minus 1 is 7. The absolute value of 7 is 7. 7 plus 3 is 10. I can put in -3. 2 times -3 minus 1 plus 3. 2 times -3 is -6 minus 1. So I get 3 plus the absolute value of -7, and that also equals 10. So here's another one where I have to isolate the absolute value first. So I get absolute value of x plus 3 equals -5. Many of you will go on to write two equations, but you can't. You have to look here. Absolute value is never equal to a negative number, so this information is nonsense, and there's no solution. Okay, so there's the explanation typed out, but after you isolate that absolute value, you always have to check. I haven't really been checking, but they've all been positive to this point. You can't forget about the fact that if you get a negative equal to an absolute value, there's no solution. So this one has a couple of steps to isolating the absolute value, and they're on the next slide. So first, I need to isolate the absolute value. I added 15 to both sides. That gave me a positive 10. At first glance, you might have seen the -5 and wanted to write no solution. But again, you can't make that decision until you have the absolute value by itself. So after I add the 15, I have to take care of the 4 in the denominator, so I multiply both sides by 4. That makes that a 1, makes the right a 40. Now I can write two equations. Absolute value of 2x minus 7 could be 40. So there's my two equations. I add 7 to both sides, divide by 2. I do the same over here, but when I add 7 to -40, I get -33. I get a different number, and that should have said divide by. So there are my two solutions. So here is some for you to try, and you can see some have absolute value isolated, some do not. You need to isolate the absolute value first. Check to see if your result is positive or negative. If it's negative, you write no solution. If it's positive, you write two equations and solve them both. So please stop the video now, try these, and then come back and check your answers. Okay, you're back. So let's see the answers. Here are the answers. Notice number 8 was a no solution because after you're isolated, you can't get it. You got a negative number, so there's no way to get that. So if you did not get these, do not just say, oh well. Find your mistake yourself, take it to the tutoring lab, email me, or take it to a classmate, or take it to me in office hours, or if we do have class meetings, meet in class. Thank you, and I will see you in the next intermediate algebra lesson.